In this example, we want to memorize a function, and we'll use the Fibonacci function. And by memorize a function, I mean make this whole function remembers the result it's it's produced in its previous invocations. And if it has already been invoked for a particular result, return that result without calculating it a second time. Obviously, this only makes sense under certain circumstances because it's a trade-off between computing power and memory. So in order to have a function which maintains its state, we have to return it from another function so that we can create a closure. So we're going to write fibgen, and this is going to have our state, which is going to be cache, and also it's going to have the fib function, which is fib of some index, which is, after we've written it, going to be returned from fibgen. And when it's returned, it's going to be closed over cache and thus keep it alive. Right, so the first question we have to ask is, do we have the result in cache? And this translates to index is lower than cache dot length. And if the result is in cache, we're going to return cache of index. And in order to see if the memorization process is working, we're just going to say console log found index. Now, if we don't have the result in cache, what we're going to do is we're going to calculate it. So we're going to say cache of index is fib of index minus 1 plus fib of index minus 2. And then we're going to return cache of index. And in order to see that our memorization is working, we're going to say console log calculated index. All that's left is to test out our function, and we're going to say first fib is fibgen, so we're going to get it from fibgen, and then we're going to log its application to a bunch of inputs. So fib of 1, fib of 5, and fib of 3. And if we run our function, if we run our module, and it's going to invoke our function, we can see that each of the values has been calculated only once, right? So, and the rest of the time they have been found in cache.